Good afternoon, ladies and gentlemen. Welcome to TechGig webinars, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Topic for today's session is Customers Don't Tell, You Have to Ask, Science of Questioning. We are delighted to have Mr. T. Ashok, founder and CEO at Stack Software Private Limited with us today. Ashok is the founder and CEO of Stack Software Private Limited, Bangalore, a company that specializes in inventing test technologies and provide boutique test solutions to deliver clean software. Passionate about excellence, Ashok's mission is to discover methods to build clean software. At Stack, he is deeply involved in architecting hypothesis-based testing, the personal scientific test methodology that is effective, efficient, consistent, scalable, and agile while trying to substitute experience with a goal-focused approach. Gentlemen, this presentation will continue for next 45 minutes and we will take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Ashok.
Yeah, Mr. Ashok, we can see your screen, but we can't hear your voice, please.
Any better? Any better? No.
Hello?
Keshav, are you able to hear me?
Yeah, we can hear you now.
Is it okay now?
Yeah, please. We can't see your screen.
Shall I continue? Okay. Yeah, yeah, I'll do it. Fine. Now, I just want to check because I was wondering is it okay now? You should be able to see my screen and you should
Yeah,
be able to hear my
screen is
voice.
visible now and we can also hear you. Please go ahead. Thank you.
Okay. Okay. Sorry for the little confusion. I don't know why, but anyway, let me restart again. So today the topic of what I want to talk about is there a science to questioning? The focus here is from the context of testing, where the primary premise is customers don't exactly tell you what they want. It is necessary that you have to ask. And that's why it's titled Customers Don't Tell, You Have to Ask. And the focus is there a structured, scientific, logical way to uncover information from customers? So typically to build software, we need to have a reasonable understanding of the specifications, which are normally given by customers. Some are written, some are unwritten. Now, customers typically have a bunch of end users, and what we are really wanting to do is to understand what the various needs of the end users are. And these end users' needs are really specifications. And the end users, within the context of a customer, their specifications are finally converted into code by the software engineering team made up of the developers and testers. In real life, these specifications are not necessarily all stated, or they may be incomplete, or they may be fuzzy. Now, as a developer, typically I make quietly some assumptions. So I end up assuming, if you will, on behalf of the customer, certain information that may or may not be given, which unfortunately is not correct. And therefore, as a tester, I'm supposed to uncover these. And my job as a tester is really not about just checking whatever is stated in the requirement, written or unwritten. It is in a larger context, it's about ensuring that the expectations of the various end users are met. So now we've introduced a few words here. We have introduced the notion of customers, end users, needs, and expectations. The expectations, these are really hard to state because expectations are stuff that I have in my mind which is really hard for anybody to uncover. Now let's take let's blow up the picture a little more and understand the fact that a customer, as we described in the last minute or so, is really a collection of end users. That means there are different kinds of end users who use my application or product within the customer in very different ways. So what are we trying to do? That each of these end users have certain needs that have to be fulfilled so that they can do the job better. And these needs are converted into features, technical features of the product or application by the development folks within the software engineering team. And as the folks who are primarily responsible for product quality, the test folks within the software engineering team, their primary intention is to ensure that the expectations are met. It is not only sufficient that the needs are done correctly, but it's more important to ensure that the expectations are met. So that's really the job of a tester. Need is what translates into feature. So it's not about just saying the feature works correctly, but it's really about the feature does meet his or her expectation, meaning a set of users within the context of a customer. So that's really what the highlight is, the notion of end users, the needs, and the expectations, and the list of end users constitute the notion of customers. So when we build software, as we talked about, we need to probably have a reasonable clarity of what is intended, meaning what are the various needs, what are the various expectations, and who are the various end users, and what are the expectations are they expecting, and therefore ensure that the application or the product makes sense in the context of customers. But really, customers don't exactly tell in black and white as to who the various end users are. It is really about saying, look, just because something is not written and given to us doesn't really mean they don't exist. And therefore, it is me as a person in the software engineering team, more importantly a test folk, who has to understand that there are different types of end users in the context of customer who would view the software differently, who would use the software differently, and so on and so forth. So it is imperative that I have to understand who the various end users are. And then, of course, I have to understand what of each end user needs, what are the various kinds of various features that they need, and how do they intend to use it. And that's very, very important, because that's what helped me to come up with scenarios to evaluate the product. And then, of course, finally, in a broad brush, I have to understand as a tester that I'm really trying to ensure that the expectations are met, and that really is good quality, and therefore it's necessary that I have to tell what the end users expect. And all these three things that you see here, or four things that you see here on the left, customers don't necessarily tell us, and therefore you really have to ask. Now the question is, how do you ask? Is there a finite set of questions? Is it not an infinite set of questions? Is it a structured process? Is it a fairly creative process? And that's really the context of the discussion as we go forward in the next 30 or 35 minutes. So what does it mean to say you have to ask? It's really about asking questions. Now, let's qualify the fact that we're looking at good questions. So what are good questions? Good questions are those that ultimately make sense to the problem, to the context of the problem. That is, the answers to those questions help us to understand the problem better or help discover a deeper set of problems. And that's really the meaning of a good question. So what do we ask? So one has to qualify the question as in terms of a good question, that which brings us answers that can make sense to the solution or help us find a solution. So the questions really are in the context of the application or the system that you're building. It's really about who are the types of end users, how do they use it, how many times do they use it, what is the behavior of every feature, what conditions govern the behavior of every feature, what are the various elements of data that are being processed, size, format, syntax, rate, and so on. What are the other attributes that are important? Is performance important? If so, what is expected? Is security important? If so, what do we mean by that? And so on and so forth. And then finally, a good understanding, if you will, of the internal system, in terms of architecture, how is the system composed, what are the various pieces, how are they composed of, and so on and so forth, the interface that exists, and so on. So I need to probably understand these kinds of information, and therefore there's a set of these questions that relate to this larger context that we will have to look at. Ultimately, questions are broad or deep, meaning you cover a large breadth, or you cover a depth, meaning understand, for example, how the data flows in great detail in terms of a depth. And certain questions are pointed and certain questions are open-ended. So this is the context that we're setting in terms of what the questions are. So now let's go one step further towards the notion of where is the science coming. And as we mentioned, that good questioning really is key to good understanding. Now some of the things that I get asked is, hey, what happens if I don't have an answer? So let's now understand. Ask a question and you may get a good answer. Ask a question and you may get a very vague answer. Sometimes when you ask a question, you don't get an answer. But the very important thing is you don't stop asking questions, you continue. Just because somebody doesn't give an answer does not necessarily mean you stop asking questions, because it is far more important to know what you do not know rather than being content with what you know. And therefore the power of questions is two parts. One, it tells us what we know and therefore clarifies, or it helps us understand what we don't know. And as a person who's trying to test an application or a product, it is quite important for me to know what we don't know, and therefore look forward to uncovering these facts as we go along. And therefore understand at any point in time, it is important to come up with good questions rather than worry whether the answers may be available. Given this entire context, now the whole idea is, how do we now, given the backbone of the fact that the questions are important because customers don't tell and you have to ask, and then the fact that it's not necessarily important that we have to have all the answers. Some of the answers we may not know. Now the big question is there a science? So let's understand what is the notion of a science. When we say anything is scientific, what it simply means is there is a very rational way of getting things done. That means there is a set of logical steps, there is possibly a set of techniques that help us to do things logically, and the outcomes are reasonably predictable. And that's really what science is all about. So now, what I'm really going to talk about is use a little story, if you will, to illustrate a point in terms of, is that a science to question? There was a person called Joe, and he was a tester. Once upon a time, he was working in an organization. He was suddenly given a new application. He was moved from another project to another project, and he was given a new application to test. Now, this application was in a domain that he was not familiar with. He had always worked in different domains, but this particular domain he was completely unfamiliar. And therefore, when he was asked by his project manager to understand the application and the specification so they can test better, he was fairly frustrated because he was finding it very difficult to understand because he didn't understand the domain. Now, when he had to accompany his friend to a doctor because his friend was unwell, and he, being a very curious tester, was observing how the doctor was diagnosing his friend who was sick. And that is when he had this aha moment. He suddenly saw parallels in how the doctor was questioning the patient to diagnose the problem. The doctor was questioning his friend, the patient, about very, very many things. He was trying to ask him his work lifestyle, his food that he ate, about his genetic background and family structure, and so on and so on. And suddenly, this curious tester, Mr. Joe, suddenly saw that the doctor was going through a process of very scientific questioning to help him diagnose the problem with the patient. And then he realized that this is exactly what he needs to be doing to be able to understand his application. And that's when he realized that the doctor was actually asking questions related to a variety of information elements, some related to food, some related to the lifestyle, some related to his habits, some related to the family background, and so on. And then he realized what he was doing was that he was decomposing the problem into information elements and establishing connection with the elements by asking good questions. And that's when he understood and said, aha, I now understand probably how to look at understanding an application. And then Joe the tester concluded that there is possibly a science of questioning, a systematic walkthrough of various elements that we need to understand, commencing from customers' needs, expectations, then the application's environment, the way it is deployed, the internal architecture of the applications, the various features that constitute the applications, the behavior the application ultimately is supposed to display in terms of the various business logic and conditions, the internal structure, the language, the technology, and connecting all these various elements actually allows a person to come up with good questions. And that's when he understood that there is possibly a science. So he started to hypothesize that there are a set of information elements that are available, and understanding each of these elements and connecting these various elements actually brings about the ability to come up with good questions which will provide us with information to allow us to do things better. Of course, the full story is available. You may go and click on it and read it. It's a nice narrative, racy kind of story that's written out there. So given this entire background, let's go delve in as to connecting the aspects of the act of science of questioning to be able to understand what customers don't really tell us. So what do we really want to do? We want to be able to understand the context of an application or a product so that we can test better. We all know that understanding is a fairly interesting piece, meaning it requires a tremendous amount of maturity, possibly a lot of experience, and a good appreciation of the domain. And that's when people say, yeah, I understand the application so that I can test. But what we are talking about here is a science of questioning, that there exists a suite of techniques that we can apply in a very predictable, organized, disciplined fashion to be able to do. So where do we start? It is very important that when we understand that we kind of be clear and ensure that clarity doesn't get lost on us. So the first thing that we need to look at is the notion of layering. The notion of looking at certain broad, higher level information that relates to the customers, then look at the next slot of data information that relates to various end users within the customer, and then look at further down, if you will, the product or the application related information, and then finally various features that make up the product. Otherwise, the chances are that we're going to be horribly confused very quickly. So what I was saying, this is like how you probably look for a location in a Google. So you go to a Google map and then you ask the Google map to show you, let's say, a location, maybe any location in India, maybe New Delhi. And then it kind of shows you the entire picture of New Delhi. As you take the camera further down, closer to the earth, you see more and more details. Under the rose level in India, you probably end up seeing the roads, the parks, the buildings, and so on. So you get to see a lot more fine-grained detail. Much like it is exactly what we're saying. So what are we saying here? At the first level, the topmost level, we need to be able to ask questions to help us understand the questions related to the customers, like where is the application going to be deployed? What kind of marketplace? Who are the various kinds of types of customers in the marketplace that are going to use the application? What is the value proposition of the application to those customers in the marketplace? And therefore, what are success factors that have to be met so the value proposition should be delivered? And each of these customers may have a slightly differential deployment environment. Depending on the marketplace and the category of customers, the environment, meaning the hardware and the software and the associated stuff, will be slightly different, and therefore we need to understand the deployment environment. That's layer one, if you will, the topmost layer. The next question, the next layer is when we come down, where we understand the customer really is a combination of end users. So what we need to be able to ask is questions related to who are the various types of end users, what are the business requirements that they need, how many such end users are there, how do they use these various business requirements, what are the various technical features that constitute a requirement, which of the features and therefore the requirements are more important compared to just being important. And by the way, what are the associated attributes for the features and requirements in terms of the non-functional aspects like performance, security, reliability, volume, usability, and so on and so forth. So that's the next layer of questions. Now, good testing is not about just understanding the external aspects in terms of customers, environment, end users itself. It's really also about appreciating the internal structure. What are the technologies used? How is the system architected? What are the interfaces? How is it supposed to work? And so on and so forth. So the next layer of in question relates to the product and application, where the focus is on structure, architecture, technologies, and of course, stage of development. What stage of development? It simply states that the entire product may not have been built from now. There are parts of the product that's being modified, new things that have been added, and certain things that have been left as it is. So what we're trying to understand is certain parts of the product may not be modified at all, may have been there for a long time, and therefore those parts could be much more hardened, meaning they already are rock solid in terms of quality, and therefore you don't have to worry too much of it. On the contrary, there might be new things that we are adding or modifying some critical things, and therefore we need to appreciate those and understand those better because they could significantly affect the final quality of the product. And then finally, at the layer 4, if you will, at the lowest level, we're trying to understand deeply, if you will, about every feature that is there in the product, meaning what are various conditions that govern the behavior, what are the kinds of inputs it takes, what is the specification of these inputs, and how do these various features themselves interact among themselves. Do they affect each other? If so, how? And therefore, that's really at the lowest level. So first thing is to kind of layer this entire problem so that it's less confusing. And that's really what the upcoming slide is going to show, where the focus is we're trying to look for specific kinds of information across its various aspects, which is what I detailed, if you will, success factors. I mean, why are we deploying the system? What is the value proposition? What is the marketplace and the customers? Who is the target for this product and application? Because a good tester is not about just testing the product technically and satisfying it. It is about really looking at the product and the way it is used, and does it deliver the intended value to the end users from the customer base. And therefore, it's very important to look at. Customers are the deployment environment. Where will it run? What is the hardware, the software, the other softwares that are probably important that they connect with each other, where will it run? And then who are the various people who are going to use the system? How many are there? And what do they need? What are their expectations? That's what requirements, features, and attributes are. And therefore, as you can see now, there is possibly 1, 2, 3, 4, 5, 6, 7, 8, 9, about 11 blobs of information, if you will, that are there. And when you really look through this entire process, some are really external oriented and some are very internal, internally product oriented versus customer and market oriented. So given this backdrop, that these are the kinds of information that we would need to test, validate the product better, and therefore understand the needs and expectations of the end users within the context of a customer. And these may not be given to us in a platter, and therefore we need to ask, and how do we do it scientifically? So we established a small premise by saying, hey, there is about 11 major pieces of information, looks like, so is that a good idea? Can we connect these information elements and in the process come up with questions? So I'm going to use two techniques within the larger context of a personal scientific methodology called HBT. There's a technique called landscaping and there's another technique of viewpoints, which is what we're going to cover, where both these techniques in conjunction will allow us to come up with a series of questions in a fairly mechanistic fashion. Now both these techniques, if you will, are part of a personal scientific methodology called HBT, or hypothesis-based testing, which really consists of a very scientific way to uncover defects in software. Probably just before we close, I'll probably give you a 1-minute overview, but right now I just want to communicate the fact that it is a methodology of testing that is individual oriented, that is personal, and there's a set of scientific techniques that are there which allow us to test. It consists of 6 stages of evaluation. It has about 8 disciplines of thinking, and it's got about 32 different core concepts, 2 of which I'm talking about in the context of this webinar. One is called landscaping, another is called viewpoints. So what is landscaping and what is it? How does it aid? How do these two techniques aid in helping us coming up with a series of questions is the context for the next few slides. So as I mentioned, landscape is a technique. This is a core scientific concept in HBT. What does this do? This simply states it's a technique to rapidly understand the system by examining the various information elements and the connections between them. So when we want to understand an application or product, as we talked about very briefly, we said there are 4 major layers that we're trying to look at information. If you look at this picture here, what you see here is it consists of various boxes. For example, there is a marketplace, success factors, customers, deployment environment, other systems, attributes, end users, and so on in this collection of small boxes. So what we're saying is, hey, you know what, if you want to be able to come up with good questions to help you understand the product, think of this as we are trying to construct a software landscape where the landscape is really made up of 16 pieces of information, broad brush information, and we are now trying to come up with a series of questions for each of these elements, and more importantly, help us connect the various blobs of information, and in the process of connection, you probably would get more interesting questions. And that is the premise for the landscaping as the whole concept. The premise is based on a very simple principle that good questions matter more than the answers, and even if questions do not yield answers, is perfectly okay, as it's very, very important to know what you don't know. So now so the basic notion of landscaping is that there are about 16 blobs of information which are spread over about 4 layers, starting from outward, going all the way inward. And we're going to ask questions related to who are the types of customers, for example, who are the types of end users, individually understanding, and more importantly, establishing the connections that are there. Now, when we talk about end users could be of 2 varieties. One, it could be physical people who use the application. The second is it could be not physical people, it could be other systems which actually talk to our application or talk to our system. So when we say good quality, we really mean that each of these end users, physical or otherwise, their expectations are met. Now, I'm sure that we've all heard this interesting term which says that if you can see the customer, I mean, if you can see the system from an end user standpoint of view, if you can put yourself in the shoes of end users, then you probably would be able to appreciate the system. Now, it's very easy to say that, it's very difficult to do. So the viewpoints is another core concept, which is another technique where it simply says that, hey, each end user has different needs, that is, different flows, different importance with respect to a feature requirement. He or she uses different features in terms of higher or lower frequency, higher volume of usage, higher rate of usage, differential importance, has different expectations of what is correct, expectations of performance, security. So some users may value performance more than security, and so on and so forth. And each end user values certain attributes more. So an end user may say, for the particular feature, I think performance is far more important than something else. And therefore, this technique called viewpoints simply states that it is necessary to view the product or the application that is being constructed from each of these viewpoints of end users, keeping in mind that each end user has differential needs, differential usage patterns, uses certain features more, less, etc., has different expectations and values certain attributes. And therefore, in this process, we're slowly trying to get into the skin of the person, into the, so that we get a much more clearer handle of the needs and expectations. And this can happen only when end users types are identified. So having done a bit of a landscaping and then coming up the first layer and the second layer, where the first layer is really about understanding the context of the customer, the second layer is the context of end user, we are ready to apply once we identify the end user to get more information in the subsequent layers 3 and 4, which is really about in the product and the features. We should be able to apply, if you will, viewpoints so that we understand this context. And now we are ready to actually come up with a series of questions. So some of the questions is what I've listed here. Please don't think of it as the comprehensive list of all the questions. But what I'm going to share in the next couple of slides is to give you some idea as to how to apply landscaping and what kind of comes. And there's an example out here. So when you're saying here's an application that I'm trying to put into place, we're really saying, here's the marketplace. And what do we want to know about the marketplace? What is the kind of marketplace that I'm addressing? Okay, so it's an application for the banking scenario. What kind of banks? Is it investment banks? Is it personal banks? What kind of marketplace? Why am I building this application? Probably there are other products on the marketplace too. But my product hopefully has a unique value proposition that I'm offering. So therefore, I'm trying to really ask, what is the problem that I'm trying to solve? What are the various success factors? Really, what is my value proposition that I am enabling, that I am having, which allows the potential customer of my product to be far more successful than others? And that's really a subset of questions when you put yourself in the context of understanding information about one such element called marketplace. Going a little further down and really asking, in this marketplace, maybe I'm targeting personal investment banking space and the banking marketplace in a large. Now, what kind of customers? Are we talking about regional banks? Are we talking about nationalized banks? Are we talking about global banks? There are various possibly maybe the types could be segregated on size, types could be segregated on a variety of other pieces, and therefore we're trying to find out if there are different classes of customer within the context. And therefore we're saying, hey, are there different categories? And how do we classify them? Is it by size? Because size could give us some idea of the volume, the size of data, volume of usage, the rate of usage, etc. And possibly each of these types could be slightly different. Maybe each of these are specific regionalized banks, then maybe there's a certain unique notion that needs to be brought into picture for each of these types of customers, and therefore need to appreciate, are there certain unique needs or different needs that are required? And therefore, that's some of the questions related to the customer type. Now, in a customer, in a marketplace, but obviously there are a variety of end users. So now let's continue the same example. In a bank, there could be a clerk, there could be a loan disbursing officer, there could be chief manager, there could be different roles of people. And these are the people probably who are going to use my application. Or there could be another another banking software, another system which I have to integrate with to transfer funds from one bank to another. And therefore, that's also another type of end user. So really understand the end user is kind of an actor. And therefore, when you look at that information element called end user and actors, some of the questions that I might come up with is who are the various types of end users or actors in each type of customer? What is the maximum number? So are we saying that, if you're saying that our managers, the chief managers in the bank, are we talking one per branch, or are we talking one per 10 branches? If you say in clerk, does it mean it's 10 per branch, and if so, how many branches? I would love to know what is the typical maximum number of physical, number of non-physical end users at every time. And that's the information, that's some questions that are. Now, one of the common things that I've always observed when you ask a question very directly in a very pointed fashion, how many such users are there? The chances are they're not going to get a clean answer. People will say, I know the exact number, but I think it's about 500. And that's pretty good enough. Because what's important to understand is in real life, all the information that's given to us in the beginning need not be exactly precise. We need to get a reasonably approximation answer, if you will, and therefore understand that approximations are perfectly acceptable. We just need to have a reasonable idea, a ballpark idea that is hopefully not too much in variance with real life. So just because you don't get a perfectly precise answer, don't discount the answer, or don't stop at not getting an answer. Focus on the fact that you want a reasonable, decent ballpark. Some of the other questions when we talk about a requirement and use case, we really are asking, hey, have users in a marketplace, what are they wanting to do? What is the business use case that they want? What is the requirement that they really want? And how important is it? Because really in a product there are a variety of use cases. Some are perceived as more important than others. It is not that anything is less important, it is just that some are more important, and therefore we need to be able to rank the requirement. Now remember, a requirement is nothing but a collection of technical features with a certain attribute, meaning it is, this is a collection of various features, and I can do this entire, the entire use case or the entire flow in no greater than 1 minute. So that's a performance attribute. So I'm interested in understanding what are the various attributes for a set of these features and a requirement that have to be met so that the product is deployed successfully. And finally, of course, ask, how can I make it very testable? Because some of these attributes could be vague, they may not be clear, they may not be articulated properly, and that's where this is. So looking at these now, what we're really saying is there are a variety of information elements like marketplace, customer type, end users, requirements, which is what has been highlighted, if you will, by the technique called landscape. And then what we are saying is, look, when you keep in mind the technique called, when you keep in mind the notion of viewpoints, applying the technical viewpoints, that each of these end users views things differently, values things differently, uses things differently, we are able to get a better understanding of each of these elements, and then starting to come up with better set of questions which may bring us some answers or may not bring us some answers. Now, is that all? No, there are probably some more, and that's what is outlined very, very quickly, in the second slide. So I'll probably give you a little brief on what some of these things mean. That, for example, I'm interested in knowing some information about the environment. For example, what does the deployment architecture look like? Is it clustered? Is it set up? Is it distributed? And so on and so forth. What are the other applications that are running in the same box? And that's an application that are co-located, stuff like that. Does my application have to interoperate with other applications? Do I have to migrate data from different products and application systems into mine? And if so, do I know the size of data, and so on and so forth? So this is about the environment. And then, of course, it is not just sufficient to know the outward stuff, as I mentioned. It is important to know what is the technology that are used, languages, components, services, and of course, the application, the system architecture. And then finally, of course, looking at the notion of usage profile, that is a customer, an end user uses a set of features. I would like to know who uses them, how many times do they use them, what is the rate at which they use them. Are there different rates of usage based on the time of the year or the time of the day, for example. Maybe some features are used more frequently toward the end of the month compared to the typical day, and so on and so forth. And then, of course, finally, the individual features related to the layer 4 that I talked about, which is really about the behavior. Because ultimately a feature is nothing but something that I want the system to do. It has to display a certain behavior based on certain kinds of inputs. So I'm more interested in understanding what are the business conditions that govern the behavior and what are the various elements of data that gets processed and what is the detailed specification. So these are some of these questions that you see that come across by within each of these elements. But remember here we also connected some of these elements. For example, we said who are the various types of users, and then we asked what are the various kinds of features and requirements. And then we said, hey, connect these two. How do users use these features? What is the rate? What is the frequency? What is the stuff? So we started connecting this information. And then we said, oh, if this person is going to use this feature pretty frequently, then I think performance must be important, isn't it? So we started to connect the notion of attribute. And then when we say, oh yeah, the idea needs to be high performance, then I need to worry about the fact, hey, is the architecture good enough? So I have to understand the architecture be connected to know that it's a high performance architecture. And that's therefore, it's not just about questions about each of the information element, it is about connecting these various information elements together to come up with a series of questions, just like how the doctor did. And that's what Joe observed some time ago. And that's really how this whole, these two techniques of landscaping and viewpoints in the context of HBT works, because they give you a better sense of trying to come up with a series of questions by breaking down the problem, if you will, into largely 4 levels, and within these 4 levels about 16 pieces of information which are hierarchically structured, and the focus is on connecting these various stuff. So now I just want to give you a little overview, maybe a minute overview in terms of what is HBT. I think I used the word. So hypothesis-based testing is a personal scientific methodology. So let me qualify it a little bit. It simply means that this is a series, this is a methodology which is nothing but a series of steps to do at an individual level, but the entire set of steps to do at an individual level are governed by a set of scientific constructs. And therefore there are 8 disciplines of thinking which is called as STEM or Stack Test Engineering Method. And these 8 disciplines of thinking are deployed in about a 6-stage manner to test any application. So the system under test, the way it works in HBT is as follows. That is, given a system under test or system to test, we want to question, if you will, the product and the requirements, etc., to be able to understand it as deeply as we can in the very limited amount of time that we all have, and come up with what we call in HBT context cleanliness criteria. That is, what are those expectations that have to be met so that if these expectations are met, then the product is deemed to be of good quality. And that is what is called as cleanliness criteria. As the term itself indicates, it's called hypothesis-based testing. So what we are obviously trying to do is to say, given this entire system under test, where we have queried with a deep and sharpened understanding, we should know in a scientific fashion, much like what we attempt to do with landscape and viewpoints a few minutes ago, to understand, go through the same motions to hypothesize as to what are the various classes of defects that could be present that could affect the cleanliness criteria of the product. And then say, in HBT, there is a very clear 9-stage filter. That means the entire HBT ultimately says there are 9 levels at which we have to remove defects, and at each level certain kinds of defects are removed, and therefore think about it as a 9-stage filtration plan, a 9-stage defect removal filter. And then finally you constantly assess as you filter the product, if you will, by removing these defects or products filter, you try to assess the cleanliness, and hopefully you therefore get the clean, if you will, or good quality system system that you're building. And that really is the entire context of HBT. So landscaping and viewpoints are 2 such techniques that are part of HBT's disciplines, one of those disciplines, which are used in the early stage of HBT to be able to appreciate and understand a product and an application. And that's really the entire backdrop. Of course, you can know more if you click about it. So now, the 2 techniques of landscaping and viewpoints which we talked about under the context of HBT to help us come up with questions so that we can understand the needs and the expectations and in a way the mind of the end users and the customer. We've done this over the last decade or so with a variety of customers. And this slide kind of gives you some snapshot of what we believe are some of the key results that we have observed. Now, as a company, we primarily test software, other people's code. That's what we do for a living. We offer specific solutions and services to test. And therefore, one of the challenges that we always run is customers tell us, here is the product, and you have to really understand it very quickly. And they give us a very short time. It could be as slow as less than a week. And if it's a really complex product, you probably would be lucky if you get about 3-4 weeks in the best case. And then in the entire span, you have to set up a team, help the team understand the entire product, be kind of ready to start testing the product, in a matter of a few weeks. Now, it is not always true that all the people within the team to understand, not all of them are product experts. So it's like not all of them know the domain, and therefore it's always a bit of a challenge. Now, what we've had over the last decade or so in the experimenting with these ideas, we have found that when teams or people in the teams apply these two techniques to understand, they're able to understand a fairly reasonably interesting and a complex product, the typical business deployed product, which has been around for some time, is being modified in about less than a week. Now, let me share with you one interesting data point. We've been working with one healthcare major, it's a large healthcare company, where they have about 30 or 40 different tools that they use to build an application. And being a healthcare application, this is an FDA, it has to pass the stringent FDA certification, and therefore it's necessary to kind of validate every tool that is being used to build the healthcare application. Now, each of these applications are quite different. Some of them are software engineering tool sets like graphics libraries, number crunching libraries. Some of them are development tool sets which allow us to build applications. Some of them are libraries for database and so on and so forth. And all these have to be some degree qualified. It's a fairly interesting challenge because it's impossible for us to assemble a team which knows everything. Now, this team over the last year or so has been kind of religiously employing landscaping and viewpoints. What we've always found that they're able to understand each of these fairly complex products in a few days by going through a fairly strict scientific approach or a scientific stream of questioning and trying to understand the product. Now, very recently, customer where they developed a fairly interesting set of components to build large-scale industrial applications to do automation in manufacturing areas, supply chain, sales, etc. Now, these are all fairly complex pieces because these are infrastructure material that is used to build a large application. So when we were actually involved with, if you will, in terms of testing, when we were applying the same techniques that we talked about and we were trying to understand some of the requirements, two interesting things popped up. One, we started finding flaws in the entire requirements. And therefore we said, what happens in this condition? And they said, that's a good question. I don't think we know the answer. That's a bug. And therefore it's a requirement issue. And therefore that's a good thing in terms of finding issues on a product without testing, without that is executing the product, a mere question. In the same product, as we started going a little further and we started understanding how the structure is, how the design is, how the actual under the course, and then when we were asking more finer questions at the layer 4, if you will, we started finding some design flaws. Meaning we found there were some very interesting bugs where the system would actually corrupt and lose data pretty badly. And that was the result of questioning the behavior, which is the lower level. So I just want to give you a notion that the discovering the defects and requirements without testing the question was kind of at the layer 1, 2, 3 kind of stuff. And whereas, the understanding the design flaws is like a layer 4 kind of stuff in the picture that I briefly outlined sometime. Whereas the understanding the complex part is kind of giving you a quick, rapid snapshot of going all the way from top to the bottom. And therefore, these were some of the results that we have seen. And therefore, this has been useful because one, it allows us to put together teams which can be indoctrinated into the scientific thinking process so that they can appreciate and understand the product and still be very cost effective. And therefore, we indeed can lessen, if you will, the dependency on the domain. Because as all of us know, a good understanding of the domain probably seen as a primary prerequisite, if you will, to be able to understand product. But now what we're doing is we are using the scientific techniques as the power, if you will, to compensate for the lack of knowledge that they have in the domain, and therefore allow a person to apply these techniques so he or she can come up with a series of questions and then therefore understand, despite the fact he or she does not have a significant amount of domain understanding. Now, there's another instance where we were working with another interest healthcare product company, and this was a startup kind of a company where it was a new product built for a completely new set of market segment. And the challenge was the requirements were very, very tough. They were like a paragraph worth of requirements. Now, if you have a paragraph worth of written requirements and you are supposed to come up with test cases, it is indeed challenging to come up with anything meaningful. So the test person kind of started looking at this requirement and then applied the landscaping and viewpoints at layer 3 and layer 4. The person came up with about 45 odd questions in less than an hour or so. And then when he confronted the person who was responsible for writing the requirement, which in this case happened to be the CTO of the company, because very, very knowledgeable person, and the developer, he discovered the developer had made quite an assumption. So the developer said, oh, I didn't know this was a question, so I made this assumption. And then the developer said, hey, you know what, if I could have answers to all these, then really have a much better spec. And then the CTO said, hey, this is very good, because I don't have the time to write all the detailed requirements, but I'm glad that you asked all these questions, and therefore the answer was supplied. And two things it did. One, a developer had obviously had a great advantage because he had a more complete set of requirements, so that he didn't have to make assumptions, and obviously had the tester because he did have now a better set of test cases to validate the product. And that's where the value of questions comes in. And this, by the way, is not because the tester who was testing the product was a healthcare specialist. It was just that he was a person who knew these parts of HPP pretty well, and therefore he could apply a fairly scientific notion to question. And that's really the backdrop. And so, as a summary, what I really want to communicate, what I want to communicate is the fact that in real life, it is not about saying, hey, if you tell me everything, I will do whatever you want. And therefore, the notion of if customer has not told and therefore I've not done is no more excuse in the current times. And therefore, customers believe and customers expect that you are the expert, and therefore you will come up with meaningful questions. And therefore, it's considered sinful if we as professionals who are experts in the act of software development do not come up with meaningful questions, and the customer didn't know about it, and therefore it turned out to be a problem in the future. And therefore, at the end of the day, understand it's necessary and important for us to ask and therefore come up with a series of interesting and good questions. The only thing is, it is important to come up with good questions and do understand that questioning is a high maturity skill. And what we are making a passionate plea here is that there is possibly a scientific way to come up with these questions so that we can understand the application of product and therefore deliver absolutely clean products for our customers and therefore deliver great quality. That's the entire idea here. Of course, I'm doing a pre-conference tutorial in our testing conference in Bangalore on the 15th of stuff on the same topic, if you will, and this is considered, this is titled, if you're interested in it, look at the link. So thank you so much for listening. I'm absolutely open for questions. So I have done my part of trying to give you some idea as to how one can look at science, or how one can be a little more scientific when it comes up to questions. So if you have any questions, it will be a great time, and I'd be more than happy to answer each of these questions as best as I can. So I'm going to answer one of those questions out here that's given to me, which the question states, if the customer is not ready to provide anything that a tester or developer needs, then what can be done in that case? That's a pretty interesting question. I think, if people are not willing to give answers because they think that they don't believe you or trust you enough, then I think you've got really more of a social problem than a technical problem here. So I think it's very important to whenever we ask questions to anybody for the matter, I think the answers are normally not given unless people know as to what are they going to do with it and have a sense of trust. So I think the first step here is, the answer to this is really to build a sense of trust, and more importantly, to communicate to the customer as to why you're asking the question, how it is going to help him or her, and only then I think there is value. Otherwise, if you end up asking questions and the customer is unwilling to let us know because he or she does not trust us, then I think we've got a hard ball here. I don't think either of us are going to benefit. Unfortunately, both of us are going to lose. How do we structure this, as it may be difficult to do virtually? So let me see. I don't think I completely understand the question, but I'm going to take a quick hypothesis of what the question could be. How do we structure this, as it may be difficult to do virtually? So I presume that sometimes we don't always meet the people in face to face, and therefore end up asking questions. We have to do this over a telecon. We may have to do this with a phone call, we may have to do it with a video con, etc. So if that is the question, then I think it's interesting to know that I think just because we have questions and we can't ask face to face does not mean we don't have questions. I think when we are particularly doing a discussion where we are not physically involved as across the table, I think the questions have to be crafted carefully. If questions are not very clear, they have to be substantive with examples very clearly. And then sometimes the reasoning as to what this question is, what are we trying to address, has to be given, so that the other person is able to understand the context. And it is not that it's as hard, because I do think we've also done a similar set of stuff of trying to understand products by going through like what you're doing now, having a webinar if you're in a product, and therefore the only thing it needs to be a little more structured, because we don't have the luxury of talking face to face, and therefore don't have the luxury of reading your body language, if you will. And therefore the notion of a well-formed structure, meaning a clearer set of questions, maybe associated examples, maybe preparation before we end up asking these questions have to be done. Some of them could be done by a well-formed questionnaires too. So you could have some standard questionnaire, and then you could use those questionnaires as a means. And you could also have certain dummy answers that you have to take product if you don't, which gives you an idea of what you're expecting, and therefore those things. Can we adopt HBD in SDLC model, or is it entirely different? Yeah, no, the quick answer is yes, we can adopt SDLC model. Is it entirely different? It is different because I think it provides you with a very differential form of thinking tools. So in that sense, it's different. But in our application of HBT over the decade has been in terms of V model in variety of forms, waterfall orientation, incremental orientation, of course, more often in the current place, agile orientation. So I think a quick answer is yes. The next question, do you recommend any specific effective tools for questioning the customer for gathering the requirement? Now, I don't know what you meant as a tool. If you meant as a software tool, I'm not too sure that you have a specific set of tools that are there. Yeah, there are typical requirements gathering tools that are there, but please do think of those tools as a nice repository of information, and they do have, therefore, a certain set of predefined information. But here, I think what we really are talking about is a set of thinking tools that, as an individual, I can deploy, and that is where the landscaping and viewpoints come in, so that I, as an individual, maybe I'm a developer, I'm a tester, a manager, whatever role there is, to be able to come up with a series of questions so that I can answer. So in that sense, I think there is no such interesting enough tool to do this exercise. But there are, yes, nice requirements management tools, yes, which allow us to capture requirements, store requirements, and keep a variety of them. So I don't think there is, per se, if you will, a set of tools or a tool which helps us ask questions directly. Of course, what we're trying to do is to kind of craft it in the same lines on HBT, so kind of the HBT toolkit, which might address one part of your question for sure. So the next question is, we are a product R&D and you do not have direct interaction with the customer, but we do collect usage profile based on customer visits, customer defects, customer configurations. Based on this, we come up with key attributes and design non-functional requirements such as scalability. Will this be enough, or is there any aspect that we need to think about? Okay. What you're doing is I think absolutely very valuable, because I think you are trying to use the experience that you gain post deployment in whatever interaction that you have, physical or virtual, and use that information to get a better understanding of the product, and like what you said, come up with a better set of non-functional requirements and so on. So I think what else you could possibly do is I'm sure that you know now that based on your interactions or based on your visits, if you will, there are different classes of customers, different types of customers, different value propositions each one of them want. So rather than just split, if you will, layer 4, layer 3 type of information, I think you could probably use it to expand, if you will, in terms of types of customers and deployments and so on and so forth, to get a little more larger holistic view. So that I think would be of some interest because I think it gives you a more bigger overview of the entire stack. Now, is there any other aspect that we need to think through? I think what you have is the technical parts, which is what you're mining from the defects. All I'm recommending is if you can kind of get a larger picture, because I'm sure the larger picture will help us and help you and your team to get a much bigger picture of its usage patterns and the usage and the requirements and so on and so forth. Now, the next question is, which model will you suggest for post-implementation support to client in case of concerned technologies outdated? Let me now try to understand what the question is trying to tell me. I presume when you say which model, it's software development lifecycle model, if that is so. And then you're saying that, so that means the question is, what I understand is, which software development model will you suggest for post-implementation support? That means the product has been released and we're doing tech support. Unfortunately, the product is an old product, so technology is outdated. I'm not sure if there's a model, and if I give you an answer, will you agree with me? But I think if it's a kind of a quick and short, it's only this kind of stuff maybe it's worthwhile. Because it's outdated and because we're kind of in a support kind of fashion, a simple mini waterfall would work far better at this point in time, because we probably have change requests coming in, maybe it's a bug, maybe it's a small feature addition, maybe it's a small adjustment, and the technology itself is fairly strict and straightforward because we're not modifying anything. So probably understanding the entire piece before we get into the modification of design or adjusting the design and code, and a full-fledged time may work. So I guess my presumption from this answer looks like the waterfall would be probably a good bet. Because I don't know how large is your typical delivery cycle. So is it like a few days, or is it like a few weeks or a few months, I don't know. But I guess that's probably one. Another next question is, thanks on the virtual questioning. Don't you think emotional aspects are missed out, which could lead to gather more details and better understanding in face-to-face meeting? Any techniques to welcome? Now, I'm glad that you didn't bring up all this, because it's a topic that I think is very finely dear to my heart, but I don't think we really talk about it in the community as a whole. And that is the aspect of social interactions in the context of software development. I think software development still is a fairly infantile kind of a notion where I think we're focused on techniques and processes and tools. And slowly, I think we are embracing the notion people are far more important, I think, as it is with the agile community for sure. Now, I do understand the importance that having a face-to-face meeting does make things much, much better. But then the fact of the matter is sometimes it's impossible. So I think what we're trying to do is to develop a certain level of trust, if you will, in a distance fashion, so that we can do hopefully as close to what you might accomplish face-to-face. And though if you ask me what about techniques, I think one is people have to appreciate the fact that since they're not going to see you, they're not interacted with you, they have to presume that you have to kind of make an impression, if you will, that you're asking good questions. That means in a way that they have to respect you for your intelligence. Now, when I say intelligence, what I'm saying is that you are a person who asks the right questions and you values the right things. So that is what I think we are communicating. Sometimes when we have a non-face-to-face, when you have a virtual kind of a discussion, and when you ask a question, the guy that way is going to think, that's a pretty simple one, why is he asking? And therefore, is the guy dumb or what? And the guy is dumb or what, why should he be interacted with? And therefore, you already make certain presumptions on the person. And once I do put a filter that I am presumably dumb, then it's a bit of a problem. Then I guess the guy is not going to have enough respect to give me answers. And I think the real notion here is to build a certain level of confidence that I am asking something that is valuable for both of us. More importantly to you as Mr. Customer. And I think that trust is what I think is really, really important. And sometimes, therefore, we might have to give some examples in the string. But yeah, we are social animals, so therefore, face-to-face obviously works far more better. But that said, these are things that I think we have to live with. So these are some of the questions that were given to me.
There are more questions I've shared with you. Can you see? Can you see them in the questions window?
I can see I'm answering each one of them, but I'm able to see whatever that I've answered is what I'm seeing.
There were more questions which were asked in the beginning of the session. So I think you might have missed.
Because they are not here apparently. Because all I can see is 1, 2, 3, 4, 5, 6, 7 questions is what I'm able to see here in my window.
Questions window, and then probably you will be able to.
Questions window. Yeah, please. Because I'm able to see 7 questions in the question window. Some have been asked at about 3:80, and the last question has been at 3:58 p.m. But I'm able to see only 8th one is coming in now. Now I'm getting some more. Maybe it's coming slowly. I don't know. So next question is it a good way to represent our queries as assumptions to client and ask them to confirm? Absolutely. No questions. Sometimes it's not necessary that question has to be posed in the form of a question. Question can be posed as, hey, here is what I think. Am I right? Now those are useful. It's like open-ended, closed-ended questions. Sometimes when we ask questions, we are open-ended. What do you think? How should it be done? So there's no precise answer the customer or anybody has to think. We do that every time in an interview. When we interview people, we ask, what do you think? And there's no specific answer. And when we ask an open-ended question, the focus is on to understand how the guy is thinking. The logic behind the thinking is what we're trying to ask. Whereas when you're asking an open-ended question, what do you think about the situation? What do you think about this behavior? Pointed questions. Here's how it has happened. What do you think about it? And the answer is probably like yes or no. So those are like pointed questions. So sometimes we have to make a choice, as I mentioned earlier. There are questions can be divided in very many ways: broad, deep, open, closed. And therefore, sometimes when the answers are, or when the questions are a little vague or it's very broad, it might be good to state, here's what I think are certain assumptions. What do you think? Maybe it's about performance. And I say, yeah, this is let's say for example, I'm doing something called volume. You say, yeah, this particular feature is used by n number of people. Each feature produces about 100 bytes of data and then is stored in a file. There are, I think, about 10,000 users, and there are so many somethings. And therefore, now I think that the total rate of data production on a monthly level is 1 gigabyte. Do you think that's right? Here is my reasoning. The customer may say, hey, I think your reasoning is pretty much right. Yeah, that's about the size of the data that's created in the system on a monthly basis. Or the guy could say, no, I think you're wrong. I think you missed the fact that the ends of the week are quite different. So it's not 1 GB. I think it's at least 50% more, and therefore that's a good answer. So I think it's a great thing to to do. How do you handle the next question? How do you handle a client who don't like to be questioned? Now you see, it is not that nobody likes to be questioned. I'm quite sure you've been in a situation that's probably asking this question. The real thing is, I think it's the notion of comfort. And remember here, we are dealing with people. We're not dealing with inanimate objects. So different people respond differently. So if you ask somebody a question and the guy is always looking at you a little suspiciously, he does not appreciate why you're doing this, he's going to say, why do you want to know the answer? Or he kind of screws up his face and he's kind of upset about it, right? So that's the social stuff. So when you say how do you handle a client when you can't get to the question, I think it's very important to help him or her understand what you're trying to accomplish and how what you're trying to accomplish is useful for the customer. And if that is not understood, then the guy is not going to be forthcoming. You see? This is like, me as a doctor trying to prescribe something which is a tough regimen for the patient, and if I don't tell the guy that he's going to suffer, he's going to have serious amount of pain for the next 3 days, but after 3 days, he's going to have a lovely life, and he's going to cooperate for the next 3 days, is important. Otherwise, the customer is going to drop that medicine, he's going to probably suffer continuously, and then after a few months, he's going to come back and say, the doctor did a lousy job. So in the same sense, understand here, we are a specialist, that guy's got a problem, we are fixing a problem, he is not ready to share, and it's necessary therefore that we have a very rational conversation. If it is not at all, if there's no rationality in the entire discussion, the guy is very irrational, then you really have a tough proposition, frankly. But otherwise, I don't think we should start with the presumption that yeah, they won't give us answers, but I think the question is very, very apt. There are people quite obviously who don't like the question, but the reason for that is you're not able to display value. You're not able to demonstrate why you're doing this exercise. Now, one more interesting question. Apart from HBT, are there any similar concepts? Now, it's not. I don't know if it's the right, if it's the right answer, but the answer to me is, as of now, I've been researching as an individual, trying to come up with the most scientific way of uncovering testing. And frankly, I've only found bits and pieces. Certain pieces help us to understand, certain pieces help us to design. But the HBT is a more comprehensive, more complete, a personal methodology, which allows an individual to flower much better and to do. So the quick answer is, I have personally not seen in my research of about 10 years an equivalent which covers the entire spectrum as a whole. But I don't want to sound very arrogant here at this point in time. But think of it as probably one fairly serious scientific methodology which covers. Because this is not a process, or this is not a tool. This is a set of thinking disciplines and tools and so on. At a level 3, next question is, at a level 3 layered understanding, can you elaborate what you mean by structured understanding? Are you referring to code, and if so, how deep do we need to go to understand it? Excellent question. As typical testers, I think we always face this question: should I be black or should I be white? So how much do I need to understand externally, how much I need to understand internally? And therefore, the big question is, how deep should I go internally? Because the products are small, products are a few million lines of code. So let me now give this entire notion of, when we say about structure, divide the structure into 3 parts. At the outermost level, structure really is about the deployment architecture, how the various systems interoperate and are deployed in the real environment. That is also a structure. It is called as deployment structure. The next notion of structure is one level lower to that, or one stage lower to that, which is called a software architecture. That is, we're trying to ask, here is an application or product, and this product and application is made up of n number of services, components, modules, subsystems, and this is how the interfaces are. And therefore, we need to appreciate what those various elements, pieces of the product are, what are their interfaces, and how do they communicate, how do they interact with each other. That's the architecture. The final level of structure is the lowest level of structure. The algorithms, the data structures, the code structure, if you will. Now remember, a large body of code, like I'm sure what you have, is quite impossible for us to understand the lower level structure very, very deeply. It has to be done only on a need-to-know basis. Don't attempt to do it across the entire product. So which means if there is a specific feature that I'm evaluating, and I probably think I have a reasonably decent structure and stuff, I may need to understand, do you use recursive pieces of code? Do you use stack extensively? Do you allocate a lot of dynamic memory? Does it have a lot of dynamic threading? So I might need to understand certain structural aspects for certain entities on a need-to-know basis at a point in time for me to do it, good testing. It is not about trying to say, my product has got 100 features, I need to understand all the 100 features very deeply at a structural level. That would be fairly difficult because one, not that it's only difficult, it just takes you too much of time, which is always the short supply. So how deep do we go? To be able to understand. Think about it like this. If you're building a new building, you will want to know the various structural elements that are used to build a building. What kind of cement, what kind of mud, what kind of steel, what kind of wood. How deep do you go? You want to understand certain parts of the structure to know that the structure that you're building, which is in this case your house maybe, will not sink, will not crack, stuff like that. So you probably are looking at certain elements of structure too, in terms of the kinds of materials that you're using, and depending on what you are, you might go as deep as possible. So if you're saying, I'm putting, if it's a hospital, and then say, look, I'm going to have certain gaseous liquids going through my tube, I would want to know what kind of tube they use because I don't want any corrosiveness in the place. Whereas if I'm just transferring the water, I just need to be sure that I'm using tube which is not corrode with the water. So definitely iron is out of question. Anything else is fine. Maybe it's galvanized or maybe it's plastic and stuff. So that is the material, and therefore that's also a note of the structure. So think about it in that fashion. Any specific methodology which explores areas of unknowns of unknowns to science of questioning. I think this question was there also there, and I think you are posting this question in the homepage there. Thank you for the question. There is always certain areas which are like the blind spots that we always have. We always try to look around and we always have some blind spots. It's always a challenge to know the blind spots, which is really the unknowns. So what we really say is, what I believe, and this is only the empirical data, I can't prove it mathematically, if you will. What I've always found interesting is that once you kind of twist your thought process and twist your mind to kind of go through a structured scientific notion of questioning, and then it becomes a kind of a natural flow over a short period of time, meaning that you're starting to come up with very interesting and good questions. Interestingly, you stumble upon those unknowns. But I don't know if there are any more unknowns, very frankly. But all I know for sure is, hey, you also didn't know, I also didn't know, but in this process of questioning, we discovered an area which both of us didn't know some time ago. And therefore, in that sense, yeah, I think we did stumble upon unknown. So think of it as that, because we are in the flow where we are trying to come up with a series of intelligent questions to help us understand an aspect very more deeply, and we are rapidly connecting various pieces, it is quite possible the act of connecting various pieces does stumble upon into interesting areas that otherwise hitherto you would not have got into. And therefore, that does give you. But now the question is, are there any more unknowns? I don't know. Because that is an infinite set. So therefore, one can never prove sadly enough that if there are any more unknowns that we have missed. But the chances of us covering some of those unknowns are probably probabilistically much higher when we do this exercise. Let me see any more questions. Can you give a few examples of how structural understanding in determining a potential defects? As I was mentioning very briefly, if there was a feature that I was testing, I would have obviously the definition of the feature in terms of its behavior. What are the various conditions it is supposed to satisfy? What are the various inputs it's supposed to process, and therefore what are the expected outputs? But here, I'm really interested in saying, what? How is it? And if you say, yeah, this uses a lot of dynamic resources, then I would say, yeah, maybe there is a possibility that if allocations releases not done in mind allocation, or yeah, this particular feature is very seriously multi-threaded. It talks to n number of things. Maybe it talks to various other components which are distributed boxes. So one, because it is multi-threaded, I could run into an issue. Second, because it is distributed, maybe there are timeout issues. And therefore, now I would look for potential defects like timeouts, race conditions, synchronization, memory, and so on and so forth. So these are certain examples of certain types of defects that I might be interested in, which can only come if I have a reasonable understanding of the structural aspect of the product. Okay, last question I think I see here is, are you practicing exploratory testing your thoughts? The answer is yes, because what I'm saying is, there are situations, when we say exploratory testing, what is really important is to have a fairly well-formed intellectual process system at that point in time, because we are trying to be in a fairly creative, exploratory mood at that point in time to appreciate and understand. And we're trying to do it fairly rapidly, and we are not within the confines of the product. We are trying to connect various elements that are there in the context that is out there. And we are discovering the context along the way as you go also. And therefore, when you use the word exploratory testing, which I presume covers all these fundamental thoughts, some of these techniques that I mentioned to you become very, very handy, because they help you to discover, appreciate, connect the elements in the context, and therefore allow you to be an explorer and be able to appreciate the larger landscape of what we are trying to do. I don't seem to see any more questions. It's pretty interesting that I seem to have covered all the questions as of now. Some more. Next question, few clients are very emotionally asked questions, how to handle them. Well, it's a human thing. I'd love to give you a more detailed exposition, but if I did that, I'm going to probably get into another detailed discussion here. A quick answer is, do understand there's nothing wrong in getting emotional after if we are dealing with people. So how do we handle them? I think it's, as we talked about sometimes, it is not just a mere act of question, because questions at the end of the day are right. I think it is important for them to understand why we ask them. It is important for them to understand how important it is for for furthering their cause, I think all the setting up of context is very, very important. Otherwise, that person either will slam up or not answer, or get emotional and get upset about it and not give you an answer, or think that you're irritating them and you're putting them to, in a situation where you're making them look like a fool, if you will. So all these are going to be natural human reactions and tendencies. So the only way that you can do it is to kind of have a certain comforting shoulder, and let's remember that you are the doctor and they are the patient. Keep that in mind always. What are the key metrics that you capture by HPT in your client projects? It'd be an interesting answer, but I'm not sure how much to be in the context of this particular stuff. But just to give you one simple stuff, I think some of the metrics that I'm interested in addition to all the things that you typically collect, is in terms of how do I know the coverage is really good enough? So we call it a notion of countability. How do I know my test cases are effective and sufficient? How do I know there's a fault traceability? And those are things that I worry about because I'm more interested in the notion of how potent are my test cases? Will they uncover those kinds of defects and so on and so forth? So other than a few other things, I just thought I'd probably touch base on a couple of them, where the focus is on how effective is my piece of work that I'm doing. How effective will I do good work? So.
Okay, I think most of the questions are answered now.
Thank you for being here, and of course,
so we can conclude
thank you
this
so much for attending this webinar. I hope it was useful, and thank you so much for TechGeek for setting this up. So it's all yours now, Keshav.
Thanks, Mr. Ashok, for your informative session on Customers Don't Tell, You Have to Ask, the science of questioning. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. Gentlemen, the next session in the TechGeek webinar series is happening today at 5 p.m. Topic for the webinar is Cloud Storage for Azure Applications. We will be having Mr. Nilesh Watke, Principal Education and Research at Infosys Limited as our guest speaker. So see you all at 5. Thank you.